laser engineer with 12 patents and over 100 publications in his field. He has given lecture demonstrations for elementary and high school students, skeptic talks at Burning Man, and has built several science and philosophy educational displays. His latest project was a solar telescope display. There's a bunch of astronomers in the audience, by the way, that would be of interest to many people. At a Nevada History Museum during the 2023 annular eclipse. The title of Russell's talk is The Influence of Postmodernism on Science Education. Russell?
So this will be about postmodernism in science education. I'm Russell Wilcox. What I'm going to say is that postmodernist misconceptions about science are being built into the standards for science education, and this is not good. First, I'm going to talk about science and the scientific method and postmodernism, and concentrating on a few key thinkers, and then I'm going to talk about the next generation science standards, which has been adopted by many states, and the parts of it that are postmodernist, at least the framing document from which the standards were derived. I'm a retired laser engineer. I retired just this last week. And
so you accepted the buyout, huh?
Well, I have a good pension. And I've spent my career inventing gadgets for big science, like the National Ignition Facility and stuff like this. But it may look like I'm decrying some kind of intrusion of left-wing ideology into precious science, and that kind of looks right-wing. And I looked at various places online to see if anybody was saying something similar, and there were only charter school fans and right-wingers. So I'm plowing a new ground here. But I'm also somebody who's been interested in science education for a long time, and I've done a lot of projects toward that, and I hope to continue now. And I also went to film school for a few years thinking I wanted to be a filmmaker, but I was at, San Francisco State, and this was a very PC place, and I got a belly full of postmodernism, so since then I've been a real skeptic for it.
That's my alma mater.
Oh, I'm sorry. Film school is much, not as good as, they don't even say the word film anymore. They don't teach film. But there are several philosophical ideas that underlie science, and I'm listing these because every one of them can be denied, and is, by the postmodernists. But one thing is that words mean something outside of themselves, and not just a game. And this is, they have aboutness to them, and this is called intentionality. But it can be denied, right? You can say, oh no, words are just some sort of a game. Correspondence theory of truth says that if you're making a statement, it's true if it corresponds with what you can observe or what there is. And the scientific method really only requires that the statement correspond with what's observed. It's another step, but a very reasonable one, to say what's observed is reflective of what there is. Epistemological realism says that your knowledge actually is about something real. And that's really it. All these things are all tangled with each other. They're not really separable. Empiricism says that in order to learn something, you can't just sit there and philosophize like Aristotle. You've got to check, you've got to look at the world to be able to say anything about the world. Metaphysical realism is the assertion that the world exists, that there's something, and most important, mind independent about the world, that it doesn't matter whether there are minds or not, or whether they know anything, that there is stuff there. Induction is very important because it allows you to extrapolate from prior experience into the future, or extrapolate from instances that you have in hand to be more general. And so, you know, you can do an experiment and you can extrapolate to all such instances all around the universe, really. And that the world is orderly. You know, it seems that it's logical, but maybe logical is only a human thing. It's extremely orderly, and you know, this is reflected in mathematics, which has been constructed to be sort of reflective of the order in the world. And again, all of these things can be denied. So, you know, I'm proud to be a human because it's possible for us to get out from being just little animals on some unknown planet at the edge of some galaxy and know things and know amazing things. You know, if you read about neutron stars or the Crab Nebula and all this kind of stuff, it's astounding, but it's beyond human. And it's sort of, you know, it's refreshing that way, and it allows you to get out of stuff that's the idea that your world is merely human, and that's sort of a guiding thing, and it's spiritual in some sense. It's better than having your universe just be the squalid corner of somebody's car. So these philosophical ideas are hard to teach. You know, they're a little bit abstract. And how could you wrap it up in a simple story that you could tell people? So I think that's what the scientific method is. It's a very, you know, concise encapsulation of these ideas around science that I've just indicated, and all those ideas are implicit, but you can have this in your mind as you do things. And I want to point out the most important thing is, the scientific method is not a method. It's not something that every scientist will put a poster up on the wall and check off the steps. You know, I mean, you could do that just yourself, but and you benefit from it. But really, what science method is it's something that people keep in their heads to make sense of what they're doing in science. There could be all kinds of scientists around doing all sorts of different things, and you wonder, well, gee, what kind of a chaotic bunch of activity this is. But no, this logic guides people in doing things that make sense, and it's a framework for their work. And so, you know, this is sort of an illustration of it. On the left, it's the check off the boxes sort of activity. And this is what the postmodernists are attacking. They're attacking this because they don't see scientists doing this, right? So it's easier to attack a straw man, but really what's happening is over on the right, and that they're in everybody's head, there's the logic of the scientific method that guides them, even though they're doing different things at once. And this tends to confuse people who don't understand science and yet criticize it from a humanist point of view. So postmodernism has various positions that they take. You know, typical of postmodernism basically is a negation of all the stuff that I said, right? No reality, no truth. Science and technology are just to oppress people. Reason and logic, you know, is not particularly valuable. Language does not refer to a reality outside itself. There's this philosopher, Jacques Derrida, who's a key thinker in this postmodernist philosophy, and he famously said something like, "There's nothing outside of text. Everything is text." Okay, so says a guy whose thing is playing with words. So it's this all is very strange, and to some extent it's kind of 1984-ish to cancel yourself out, you know, to negate your own truth and reality. And one of the key the ideas in this view of the world is constructivism. So to postmodernists, any knowledge is constructed by people. You don't discover something. There's no pre-existing reality that you examine and find things. You make them in concert with the other people. You know, this is a social function. So they always talk about construction. There's a book written by one of the guys I'm going to mention here that's called Constructing Quarks, where you look very closely at people theorizing about particles physics, and but they were constructed, right? They don't really exist. And one other thing is that education. Well, I'll just read this in this strong social constructivism is a philosophical approach that tends to suggest that the natural world has a small or non-existent role in the construction of scientific knowledge. You know, it's pretty amazing, because that's exactly what science is supposed to do. It's supposed to look out at the natural world and learn about it. So it just rips that right out of there, and we'll see some effect of that. And the new philosophy leaves room for historical and sociological analysis, okay, of the processes which lead to the acceptance or otherwise of new scientific knowledge. So what they're trying to do is set themselves up so that they can know no science, but they know people and communication and society, and they can critique science from that point of view, right? So you rip the science out of science, and then you examine it, and then you decide what it is about. This sociology of science is right in parallel with, approximately, in the academic world, under social sciences and in the humanities. Education, well, okay, and education is parallel with that, right? So I'm saying that education being in the social sciences department that's a problem. It should be in science, but it's not, and that's why you have this strong influence. So one of the important people in the sociology of science was Thomas Kuhn. He actually taught for a while at UC Berkeley, and he broke down the history of science into these various epochs, separated by revolutions. Okay, so relativism, and historical relativism, was a popular idea when he was theorizing in the 1950s, and this this scheme makes it so that he can be a relativist about science, right? Because what he does is he has these paradigms that rule these epochs, and the paradigm actually conditions all your observations so much that it determines what you discover or what you think you've discovered. And since those measurements are controlled by the paradigms, you can't compare the measurements before and after a revolution when you change paradigms. So therefore, it's impossible to show that you've made any progress, from one paradigm to another. Let's say classical physics versus quantum physics, all right? The paradigms are so strong that you can't say that it's better if you have quantum physics, because, well, you can't even compare the measurements of the fundamental quantities. So another person is Paul Feyerabend. He taught for a while at UC Berkeley, my alma mater. And so his idea was, it's better for people if science is sort of anarchic and it's not exclusive, and it's not it's sort of oppressive. You can say people are wrong. Well, this isn't right to sort of oppress them that way, and so it supposedly allows for better science because there are more ideas. So anything goes, is what he says, and he's, absurd ideas, ancient beliefs, religion, politics, bring it on. And in this book, Against Method, obviously the scientific method, I suppose, is that Galileo, as an example, was a con man, and he was fooling people into thinking that he had the observations to back up his assertions of, well, the sun moves around the Earth, and the Earth is not stationary, and look, there's satellites around Jupiter, and look at all these things going on the moon, with his telescope, right? He's his main instrument. And so therefore, Feyerabend tries to attack the viability of these measurements by saying, well, he couldn't possibly have been right. These measurements had to have been wrong because, well, the observation of the sky is completely different from observation of the ground, and all these picking at all these different issues that I don't know. Ultimately, I recognize that Feyerabend doesn't understand how a lens works. He doesn't understand what a telescope can tell you and what it can't. He's fundamentally ignorant in some sense, but he considers himself superior, and this is kind of typical of these guys. But he did this supposedly for humanitarian reasons, because well, he hoped and he was helping people, and he wasn't really. And it's just an example, a graphical example of how he was unfair to Galileo, in that here on the left, there's Galileo's drawing of the moon. On the far right, there's the image that got published in the book of, well, look, the moon looks like this. It doesn't look anything like Galileo's picture, but no, Galileo did pretty well. He didn't get the proportions right, but he pretty accurately drew what was there, and so Feyerabend is pretty much a scoundrel. So this is Bruno Latour, and I really go after him because there's 3 references to him in that NGSS framing document. So here's his picture. This is Bruno Latour's picture of the process of science. But what he's doing is he's saying, well, look, there's a statement in science. He's a quote from a book or something. Now let's put quotes around that, and let's put it in somebody's mouth. Somebody said this one time. They asserted it, and there was some kind of a discussion. There was some disagreement, but eventually someone was persuasive enough to get everybody else's assent, and they all agreed for whatever rhetorical reason, and then it got put into a book, and that's why it's there. You have orthodoxy. And of course, there's no science in this picture of science, but this is what the sociologist sees. And Latour is famous. He put himself on the map by going into the Salk Institute, and after Jonas Salk had won the Nobel Prize, it's a nice lab, and he goes in there and he observes, and this was okay to observe, but he made a jerk of himself, and I could tell all kinds of stories, but I don't want to. And the stories are in his books, by the way. He embarrasses himself with these stories, I swear. But he came to the conclusion that science is really about writing and discussion, and he looked at experiments. Experiments are just graph-making machines to bolster the rhetoric of your scientific papers, because you can put these nice graphs in, even though it might be like, $4 billion is this experiment, but no, it's just to make graphs. So, and he sets himself up as in opposition to the scientists, because what he decides is that the rhetoric of scientific papers is there to bludgeon the dissenter into submission, okay? I mean, it can't possibly be there to communicate with other scientists doing similar work, because how many of them are there anyway? There's hardly any of those people. This must be to communicate to people who might otherwise disagree. And he says, it's not only words that are now lined up to confront the dissenter, not only graphs to support the words and references to support the whole assembly of allies, like a gang, right? Not only instruments to generate endless numbers of newer and clearer inscriptions, but behind the instruments, new objects. And he goes on and on. I mean, the paragraph is twice this large. Dissenters have now done all they can do to disbelieve, disaggregate, and dissociate what is mustered behind the claim. So that's his position. And you know, at one point he goes into somebody's lab and acts that way toward the guy, you know, and asks all kinds of questions as if he doesn't believe that there's anything behind it ultimately. And they hollered at each other, and you don't know who the scientist is because he probably threatened to sue. You know, so he's a jerk. He's an ignorant jerk. I you know, conclude scientifically. You know, one of the interesting things is he also, you know, of course, if they're going to deny the influence of nature on science, nature cannot be the explanation for why people reached a scientific conclusion. He says, we can never use the outcome, nature, right, because science constructs nature, to explain how and why a controversy has been settled. So it must be rhetoric because it can't be nature, because you construct nature with science. So, you know, it's an upside down world that they have. Like, do people agree about a statement because they find it as true, or do they find it as true because they agree on it, right? And it's interesting, this sort of, this mirror world, right? It almost looks like the world, but it's reversed. Andrew Pickering is important in emphasizing this idea of practice. Scientific practice is what scientists do. And there's kind of an asymmetric struggle between people wanting their machines, which is these experiments, to do something, and this being difficult. But they eventually do it. And the idea of these are reflective of natural laws, well, that's just a myth that's constructed after the fact by the scientists. And so, you know, there's all this random, you know, unpredictable activity, scientists doing everything all over the place for no reason, and then there's a kind of a ringer that it all goes through, and it gets flattened and the water comes out, and this is constructing this nice, tidy scientific story about, you know, nature and all that kind of stuff. So that's practice to him, and yeah, these flatten them out, and this is the metaphor. So if you take this attitude toward what's going on in science, you get things like this. This is a diagram from a website of the Paleontology Museum of UC Berkeley, and it predates the next generation science standards, but you know, you can tell that things are already developing. And if you read all the text behind this, and there's pages and pages about every one of these little circles here, then you know it sounds just the same, right? These ideas have been developing for a while. But I like this diagram because at least it's detailed, and you can see residue of the scientific method. Kind of, you start with the top circle, and then you go down to the top half of the middle circle, and then you go down to the bottom half, and that's kind of the scientific method. But otherwise, it's just arrows pointing in every direction. And these little circles, they have lines between the items in them, but they don't have any arrows, and I don't know what you're supposed to do with those lines. And you can't tell what to do next, and it's not a flow chart. You know, they call it a flow chart. But this is a good picture of the confusion that the postmodernist view of science gives you. And people write in and they say, oh, thank you, you know, I love the nonlinear representation, which of course is much more like how science is done. Somebody else says, we are trying to change the thinking from scientific method, with quotes around it, of course, which our teachers have used for years, along with some of the other misconceptions. Okay, so we know where that's going. This is a real flow chart. It's got a logic to it. It's got arrows that go in a certain direction. There's an input and an output. And by the way, it's nonlinear. You know, it's not a step-by-step only in one line. It's like there's branches, okay? That's what a real flow chart is. What this diagram I just showed looks more like is a crazy wall, where there's connections between this and that, and you have no idea what the logic is. So now we get to the next generation science standards, and this was a really serious effort, and important and good, right? They're trying to improve science education. They did this under the auspices of the National Academy of Sciences, the National Research Council. Eugenie there is credited with helping them, and this standards that resulted from it, right? What I'm showing here and what I'm going to criticize is the framing document that they wrote. It's sort of the plan for the high-level plan for the standards. Then the standards were derived from that, and then so many states have adopted them. So it's good to make science education better. That's receives my approval, of course. It organizes the education over the various years of K through 12, so you're not just repeating, or you're not stopping and starting at a different point. It sort of builds. That's good. Hands-on learning, student engagement, all of those are strong things. You know, I think that if you don't get your hands on stuff, you're not learning science, you're learning about science. And engineering is in there, although it's sort of the opposite. You know, in science, you sort of take apart nature and you learn about the various parts, and then how they work, and then you reintegrate those to make gadgets in engineering. So there's a section of this document where they show the 3 dimensions. Is sort of the core of it, is these 3 dimensions of the plan. And going, well, from bottom to top, right? There's the disciplinary core ideas, and that's real science, and that looks just like any science education would look like. And then there's, coming up from that, cross-cutting concepts. Number 2, this is ideas that are common to all the scientific disciplines. And of course there are, because there's something similar about the study of these various different aspects of reality. You could use that to integrate them together and make them make sense, but I think that's lacking. But really, the idea, what I think is the core of this ideological thing that I'm objecting to is the first one, the science and engineering practices. And this is where they pretty well explicitly toss out the scientific method, replace it with the idea of practice, and, well, we'll see, refer to a lot of postmodernists. So, and I'll read a couple of things. The idea of science as a set of practices has emerged from the work of historians, philosophers, psychologists, and sociologists over the past 60 years. And that work is on the postmodernist side, right? Sociology of science, etc. That, I think, is what they are referring to. This work illuminates how science is actually done. And we look at the references, right? There's Collins, major sociology of scientific knowledge guy. There's Pickering, who we saw, Latour, who we saw. Seeing science as a set of practices shows that theory, development, reasoning, and testing are components of a larger ensemble of activities that includes networks of participants and institutions. And networks, Latour's approach got eventually called network theory. Okay, and so again, Latour and somebody who thinks objectivity is when you get diverse people to agree. Our view is that this perspective is an improvement, and of course, it minimizes the tendency to reduce scientific practice to a single set of procedures. That's obviously a reference to scientific method. Later on, the notion that there is a single scientific method of observation, hypothesis, deduction, they left out experiment, and conclusion, a myth perpetuated to this day by many textbooks, is fundamentally wrong. 44, Bauer, he wrote an entire book called Scientific Literacy, Science Literacy and the Myth of the Scientific Method, okay? An entire book attacking scientific method. So what scientists do, right, that's science. Those ideas that I showed you, those philosophical high-level things, those are gone. Here are some various words that you would hope would be in a document about science and what it really is. And note, the word truth appears 0 times in 400 pages, but construction and constructing, when I mentioned that constructivism is 60 times. They dare not write the word truth without putting quotes around it, because of course everybody knows that it's empty in there. And they have a diagram too, and their diagram, I've tried to make any sense of it, and it doesn't make any sense. I can't even find a residue of the scientific method in here. It's just scattered everywhere. And I claim this doesn't help anybody, because how can you teach this stuff, again, that has arrows going in every direction, right? It's like, and look at this, look at the center circle there. It's like, well, are you supposed to go into that circle and then exit at some random direction? Oh, right. Well, that to me looks like an old pinball game. Very frustrating. That disc there between the devil's legs catches the ball rolls onto it, and it gets caught for a few revolutions and then thrown out randomly in any direction. So that's what that thing looks like to me. So, they did this, they formulated this whole new plan because, well, the old way was failing students. The outcome is poor, and there are these international assessments of math and science proficiency given to high school students, periodically, and we are always near the bottom. There are other reasons why that there might have been a failure there. Blaming the scientific method, blaming the particular approach may not be valid. But there's also a lot of questions that I'm going to try to answer going forward. I mean, this topic deserves a book. Whether I write a book or not, I don't know, but I know that there's a lot of more information there that needs to be brought into this. And one is things, well, how does this stuff filter down? These ideas, how does it filter down to the actual students, right? In the actual classroom, is it a benefit generally? I mean, boosting science and making it more important for students to take this and integrating it more. Gee, it ought to have a positive benefit. But you don't know, are the beliefs of students then formed by what they get and what they don't get? Does this integrate with college courses? Are there differences between science and non-science majors? There's a lot of interesting questions there. So one thing I want to say is the ripping out basically the guts of science, tearing it away from these concepts of nature, takes away a kind of a spiritual path. See, because you'd like a connection to the infinite. You'd like a connection to something that's beyond human. And so, you could study particle physics, or you could study astrophysics or something like this. And it would be fulfilling because, you're not just limited in scope. Again, you can be proud to be a human. If that's gone, well, religion has a story to tell you. So that it might be that high-minded students lose interest in science because it's presented in a way that doesn't satisfy this desire for meaning that people have starting in probably high school. And scientists who believe in things like nature and truth, what a bunch of fools. In fact, really the story that the postmodernists are telling is that they lie about it and then they cover up their lies by all this sort of mythology. And what are people going to do when there's a dictator who makes some kind of a pronouncement that it is about the world, and the scientists have to say, no, you're wrong. The universe says you're wrong.
That'll never happen.
So, some suggestions about what can be done, bring back the scientific method, restore the worldview that I say is lacking, and move education into the science department, because really it's a thing that you can take data on and you can see what works and what doesn't, and scientists need to get listened to. There need to be more people communicating about it effectively to the public, and who knows how you do that these days. But that's all I have to say.
Various components. People said, but how do you get into it? They were looking for a linear progression, kind of like you are. How do you get? You can't get into it. That's the point. The point is this is an iterative process, and you come up with a conclusion, and then later on, maybe somebody else, maybe it's 2 weeks later, maybe it's 15 years later, somebody comes up with an observation. You got to go back and do the whole thing all over again. Science is an iterative process, and when people complain about, you can't say the word truth in science, the context of that is that there is so much of science in which if you say, well, now we have the truth, then people stop looking. And unless you keep looking, you don't find how much more you have to learn. And I think there's been a real rethinking in philosophy of science of how the process of science is not just iterative, but it also is rarely complete. There's not, the Rumpelstiltskin theory of name it and nail it. Now we can go on to something else because we completely understand this particular principle. There's almost always a way of coming back and building upon what you've had before. And that is what they mean when they don't use the word truth. Because they're very much worried that when you use a word like truth, given the context of the use of the word truth in the public as a whole, as opposed to outside the philosophy of science, it is something that is unchanging. And there is very little of science that is unchanging. But like I say, we could have probably a long discussion about how much, if any, the NGSS actually reflects postmodernism. I would say that it doesn't even, it might reflect some weak postmodernism, but I don't think Bruno Latour got much success in getting his ideas into the NGSS. But I very much appreciate your talk, and I think we all learned a lot from it.
All right, well, thank you. Okay, lots of points, right? But I think that the idea that there's a state of affairs in the universe, but we don't know it exactly, is a very good one. Because there's a goal, there's something that science can point to, we sort of triangulate on. And that would be the truth, right? And things get more and more true the more you approach that. See, I actually, maybe I have a particular perspective because I'm an engineer, and I need things to depend on. So if I can depend on something to build a gadget, it's the truth. Because there's a very good probability that I'll be able to use it. Okay, so I'm going to treat it as the truth. And I'm not going to doubt things that are well established because there's no point in it. I mean, philosophically you could, but it's impractical.
And as you say, engineering is really the obverse of a lot of science.
Yes.
I spent a lot of my professional career arm wrestling with the scientific creationists, and when you looked at the people who were members of scientific creationist associations, they were disproportionately engineers, I'm sorry to say, because they have this fairly, if you build it right, it works, and then you can stop, as opposed to science being much more of this iterative and jig-jaggy thing. But I apologize for interrupting your train of thought.
Okay. Well, I think the idea is too that, like, if you were to teach, you could teach both things. You could say, yes, there's a real world. Yes, there's an ultimate truth that we're heading toward. But it could still be an iterative process, like I showed with the flow chart. There's a logic to it, and the logic motivates people, and it makes things possible. I don't know. We'll have to talk and talk.
That's what they make lunch.
We had a question over here.
Yeah, good question.
Yes, I'm not a big fan of postmodernism, to say the least. There's a great book called Cynical Theories, which actually dives into postmodernism in all its facets. But I think you are missing the distinction between science and scientists. Science is the pursuit of objective reality. Scientists are a herd of independent minds. They act, you had this chart about forming consensus and orthodoxy. We are living through an interesting orthodoxy. In fact, we're in the right company here. It's called AI. AI will either save the world or destroy it. It will cure AIDS and it will completely change our world. And everybody's saying it because everybody else is saying it. One day, NVIDIA stock will tank and it will be over. We had mindfulness for a while. Remember mindfulness? That was the cat's meow. You know, it would treat all your psychological problems, you will live in the now, you know, and then kind of, you know, it popped. I think The Simpsons had a hilarious thing where the teacher said mindfulness. No, now we're teaching children JavaScript, you know. The other example is climate change, you know. Very hard orthodoxy. There is a guy, his last name is Kunis, I forget his first name. He was an advisor to Obama on climate. He recently published a book called Unsettled. And he was not arguing that climate is not changing. He was arguing that the statistical models maybe were not complete or firmly established. And he was wolf-packed by the scientific community. How dare he say this, that the planet is on fire, and he's raising all these doubts. So no, science is great. Scientists is something else altogether. And I totally understand people who are not scientists in not believing what scientists do, because I think they have a good reason not to. So I guess I had a little rant.
Yeah,
what?
if you have a comment.
Well, there's a difference between obviously the subject of science and what people do, but there's degrees of certainty and there's degrees of what I'm calling truth, that you have to not just throw out all science because some of it is not trustworthy. You have to, you have to choose how much you're going to believe, because you need to, and it's the most reliable thing generally, but you don't have to worship it. So.
But if you're not a scientist, you have no way of discerning that. You know,
well, that's what the
you're a
science
scientist, so you can do
communicators
this,
have to do.
or you know, normal people, civilians. You know,
Yeah,
they might not have this.
that's a huge issue. That's a huge issue, and that's how the science communicators have their work cut out for them. I guess we're going to have to